All right, this is going to be the solution guide to the first page of our balancing chemical formulas packet. So I'm going to just demonstrate kind of how I would go about doing this. First thing I always do is I do an atom inventory. So I'm going to tell the number and types of atoms I have on both the reactant and the product side. Okay, so I look over here. It looks like I have 2 potassiums. Oxygens, I have 1 here and I have 1 here. Since they're between 2 compounds, you add them, right? So 1 plus 1, we have 2 oxygens. And it looks like I have 2 hydrogens. Okay, I don't need to count those oxygens, I already accounted for them. Okay, on the product side, I have 1 potassium, 1 oxygen, 1 hydrogen. So all you need to do is put a 2 here, and that's going to make all these 2, and you're balanced. All right, this next one, let's see, I have 1 aluminum present, I have 2 oxygens. On this side, I have 2 aluminum, and I have 3 oxygens. Okay, let's see here. Normally, you could put a 2 here, and that would fix the aluminum. But if I have an element all by its lonesome, like aluminum is here, I'm going to leave it till the very end. Oxygen, I have 2 and 3. The common factor of 2 and 3 is going to be 6. So if I put a 3 here, 3 times 2, this turns into 6. How do I get 6 over here? I need to put a 2 in front. That's going to make 2 times 3, I have 6 oxygens. But at the same time, it also changes my aluminum to 4. Okay. Then all you have to do is put a 4 in front of the aluminum, and you're good. 4, 3, and 2 are the coefficients. Okay, let's see here. Next one. All right, I have 1 silicon, I have 2 oxygens, I have 1 hydrogen, I have 1 fluorine. I'm going to go in the same order over here. 1 silicon, oxygens, I only have 1. Hydrogens, I have 2. And fluorines, I have 4. Okay, silicon looks good. Oxygen, I have 2 and 1. So if I put a 2 here, oxygen becomes 2. My hydrogen turns into 4. Okay, how do I get an equal number of hydrogen? Well, if I put a 4 here, hydrogen becomes 4. Fluorine becomes 4, and lo and behold, it's now balanced. So 1, 4, 1, 2 are the coefficients used for that one. Number 6, let's see. I guess it's not 6, but we have 1 carbon. Let's see. Hydrogen, we have 2. Oxygen, we have 1. Over here, I have 1 carbon. I have 2 hydrogens, and I have 1 oxygen. Oh, this one's already balanced. Okay, that happens sometimes. Okay, that's not a bad thing. It's not super uncommon. Okay, but you also have to realize it's not super common either. It's not like every one of these is already going to be balanced. So it's important to note that, yeah, are there ones where they're already balanced? Yeah, sure. But if you're coming up with every one of them saying already balanced, you probably are making an error somewhere. So, yep, that one was already good. All right, let's see here. We have 1 potassium. Notice we have chlorate here, but chlorate does not appear on the product side, so we have to separate it as separate elements. So there's 1 chlorine, and I have 3 oxygen. Over here, I have 1 potassium, 1 chlorine, and I have 2 oxygens. Okay, potassium and chlorine looks good. I have 3 and I have 2. Common factor of 3 and 2 both go into 6. If I flop a 3 here, this turns into 6. I'd have to put a 2 here to make this guy 6, but it also makes both potassium and chlorine 2. Well, how do I balance that? I put a 2 here. These both become 2. 2, 2, 6, 2, 2, 6, 2, 2, 3 are the coefficients. All right, next one. Okay, same compound, potassium chlorate. Notice there is not chlorate on the other side. 1 potassium, 1 chlorine, 3 oxygens. On this side, 1 potassium. Oh, nope, sorry, there's 2 because there's 1 here and 1 there, isn't there? So, yep, you got to make sure you get them all. So there's 2. There also are 2 chlorines. And then I have 4 oxygens. All right. And so if I look at this, I could put a 2 here and it would balance the potassium and the chlorine, but then notice the oxygens would be out of whack. Because if I put a 2 here, that'd be 6, 6, and 4. Yeah, that's probably not going to work. And so you don't always have to go in order. I mean, you would probably come up with the same answer either way. Let's just try that. We can do it, and I'll show you kind of what happens. So let's say you do that, and these both turn into 2, and this guy turns into 6. Now we have 6 and 4, and you're like, well, what's a common factor that both 6 and 4 go into, or multiple, I guess, of those two? Well, 6 and 4 are both factors of 12, right? So we're going to have to go back and do some changing, which is fine. Okay, if I want to get 12 oxygens here, I want to put a 4, because 4 times 3 will give me 12. Okay, and at the same time, both your potassium and your chlorine will become 4. Well, how do I make this guy 12? If I put a 3 here, 3 times 4 is 12. Okay, now I have 3 potassium plus this one, that's 4. I have 3 chlorine plus this one, which is 4. 4, 4, 12, 4, 4, 12, 4, 3, and 1. Okay, next one. This is one that has some polyatomics. You'll notice sulfate appears on both sides. You'll notice hydroxide appears on both sides. If you see polyatomics that appear on both sides, both the reactant and the product side, it's generally going to be easier to leave them together. All right. Let's do our inventory. It looks like 2 aluminums. Notice this is 3 sulfate groups. Okay, so the parentheses of the 3 outside means there's 3 of everything inside, 3 sulfates. I have 1 calcium. I have 2 hydroxides. Product side, 1 aluminum. Sulfate, I have 1. Calcium, I have 1. Hydroxide, I have 3. And notice I mirrored the same order, all right? 2 aluminum and 1. Let's start by trying to put a 2 there. That's going to make aluminum 2. It's going to make my hydroxide 6. 3 sulfate and 1 sulfate. If I put a 3 here, sulfate definitely turns into 3. Calcium turns into 3. 1 calcium and 3 calcium. If you put a 3 here, 3 times 1, that'll give me 3. And then 3 times 2 for the hydroxide turns that guy into 6. 2, 3, 3, 6. 2, 3, 3, 6. 1, 3, 2, 3 are the coefficients. Okay, last one on this first page. Let's see, atom inventory. Notice there is a phosphate over here, but no phosphate on the reactant side, so I need to separate these as elements. Looks like I have 4 phosphorus. Oxygen, I have 10, plus this guy is 11. Hydrogen, I have 2. On this side, phosphorus, I have only 1. Oxygen, we have 4. Hydrogen, we have 3. Okay. 4 phosphorus and 1. If I put a 4 here, phosphorus becomes 4. Hydrogen becomes 12. And oxygen becomes 16. Okay, this happens on occasion where I get like 2 numbers. I look at like 11 and 16. Those numbers don't jazz me up. Okay, when I look at 11 and 16, it's like, man, a common factor that goes into 11 to 16. I can't think of one except for 11 times 16, which is going to be what, like 176. That's probably not going to be a number of oxygen atoms I want to deal with. So as you're balancing, if you ever come across one of these numbers that has kind of like a not fun set of numbers to come up with common factors, skip it. Okay, you can skip it because if you look at the next one, 2 and 12 is going to be way easier to factor, right? 2 and 12, all I have to do is if I put a 6 here, 2 times 6, well, that gives me 12 hydrogen. Look at the oxygen now. Here's 6 and here's 10. Well, 6 and 10 are 16. Hey, we just fixed our problem. 4, 16, 12, 4, 16, 12, 1, 6, and 4. All right. So that was the first one. I'm going to have you guys practice another page. All right. Thank you.